Okay, class, so we're going to do quotient rule part 2. And now that you know how to use the quotient rule, we're going to apply it to answer different questions. So if you read the directions for this problem, it says, find the equations of the tangent line and normal line to the graph of the function at the x value. So this question is not directly asking about derivatives, but it is asking about a tangent line and a normal line. So let's start with the tangent line. And just to recall, a tangent line is y minus y1 equal to f prime of x times x minus x1. So in point slope form, I can insert the point and I can insert the slope, which is a derivative at that point. So if we are to solve this problem, I notice that I already have an x value, right? This is a pi right here. But my x1 value is this x that's given to me. Well, I also need a y1 value, so how would I find that y1? Good, so you actually have to, step 1, I'll type it in, plug in x value into f of x, to find y1. So let me make it my subscript, y1. So it'd be easier for you guys to read. So let's go ahead and do this, right? So I am going to take f of pi over 3, and I'm going to plug it in. So sine of pi over 3 over 3 times pi over 3 minus 5. These 3 cancel, and I get square root of 3 over 2 over pi minus 5. And since I don't like fractions and fractions, I'm going to simplify and bring my denominator down to the bottom to get square root of 3 all over 2 times the quantity of pi minus 5. This is my y1, which I can then plug in, and actually let's plug it in a little bit later. So I found this. Now the only piece missing is my derivative, right? So the next step, let me go ahead and label these correctly. Step 1 right here. So my second step is step 2. I'm going to find f prime of x. Okay, so let's do the quotient rule. Since in our problem we have sine of x and we have a 3x minus 5 in the denominator. So I'm going to take this derivative and I get f prime of x is equal to the bottom, so 3x minus 5 times the derivative of the top, which is cosine of x, minus the top, sine of x, times the derivative of the bottom, which is 3, all over the bottom squared. So 3x minus 5 squared. So I'm going to plug in, actually, well, now that I have that, I'm not going to simplify this because my next step is, now that I have f prime of x, I need to plug in my x. So step 3 is plug in x value, value into f prime of x. Alright, so let's go ahead and do that. My x value, if you remember, is, let me see. My x value, if you remember, is pi over 3. So here's what I'm going to do. I'm going to write out pi over 3. And I'm going to try my best to, type this up for you. Okay. My apologies, I'm having some technical difficulties. But let's continue. I'm going to plug in my x value into f prime of x. So I'm going to get, right here, f prime of my x value was pi over 3 is equal to 3 times pi over 3 minus 5 cosine of pi over 3 minus 3 sine of pi over 3 divided by 3 times pi over 3 minus 5 quantity squared. So let me go ahead and extend this page. And if you notice, my 3's are going to cancel out right there, as well as right here. And if I simplify this, I'm going to get this is equal to pi minus 5 times cosine of pi over 3 is 1/2. Okay, that's a 1. Minus 3, and from earlier we know sine of pi over 3 square root of 3, not over 3, but all over 2, divided by pi minus 5 squared. And once again, I don't like denominators in a fraction. I don't like fractions in a fraction. So I'm going to push down my common denominator of 2. And what we'll get is pi minus 5 minus 3 radical 3 all over pi minus 5 squared. So if I have to go back to the problem, you still notice we're not done because I need to write an equation for the tangent line. So let's go ahead and fill this out. And if you can take a look at your sheet, we get y is equal to. I get y minus y1, and we found our y1 to be square root of 3 over 2 times pi minus 5 is equal to f prime of x, or f prime of what we plugged in, which is this answer right here. So I'm going to be lazy, and I'm going to clone this so that we don't have to write it again. But here goes that right here. And to finish it off, I get x minus our x1, which is pi over 3. Good. And so, if we take a look at this, I'm still not, oh, you know what? I'm sorry, I forgot a piece. I forgot that we told you to bring this down, and I forgot to copy it in here. So there is a 2 right there. Okay, so this is the equation of the tangent line. My directions also ask for a normal line. So just to recall, the normal line is, and I'll write it right here. The normal line is still using point slope form, and so I'm going to continue to use the slope, the points that we have. But since I'm perpendicular to this line, I need to take the negative reciprocal. So what I'll do is I'm going to take the reciprocal of this, which is 2 times pi minus 5 squared all over pi minus 5 minus 3 radical 3, and I'm going to stick a negative in front of it. Alright? And then I'm going to continue and do x minus pi over 3. So here is your tangent line, and here is your normal line. Good. So let's do another one. So let's do another one. And as you can see, this is a slightly different problem because it's saying find the derivative with and without using the quotient rule. So let's first do this with the quotient rule. So I'm going to take my top right here, and I'm going to take my bottom right here, and then we're going to use this. But before I do that, I'm going to want to rewrite this because as you can see, I have a square root. And so let's rewrite this so that way I can use my basic rules. So this should be rewritten as 3x to the 1/2 minus 5x squared all over 2x. And now we can actually do this. So I'm going to take f prime of x is equal to the bottom times the derivative of the top, which is 3/2 x to the negative 1/2 minus 10x minus the top, so 3x to the 1/2 minus 5x squared times the derivative of the bottom all over the bottom squared. Right? So if we simplify this, let's go ahead and see what we get. We are going to get f prime of x is equal to, and I'm going to have to distribute these over. As you notice in the first one, my 2's are going to cancel, and I'm going to get 3x, and I have a 1 up here, and I have a negative 1/2. That's going to give me a positive 1/2 minus 20x squared from distributing here. And then I'll distribute these together, so I get minus 6x squared plus, because the negative here is a negative 10x squared. I'm sorry, positive 10x squared all over 2 squared x squared is 4x squared. So if I continue to simplify this, I do have like terms. And so let's take a look at this. You know what? I made a mistake over here. Now I forgot my 1/2 right there. So I'm sorry, let's go ahead and continue like I said. So I get f prime of x is equal to 3 square root of x minus 20 plus 20 gives us the minus 10x squared minus 6 radical x all over 4x squared. Well, if you do this, what you'll notice is we actually have more like terms. I have the square root here and the square root here, and if I am to simplify that, I'm going to get a negative 3 radical x minus 10x squared divided by 4x squared. And if I break this up, since I do have one term in the bottom, I will get negative 3x, and I'm going to write this as the 1/2, over 4x squared minus 10x squared over 4x squared. So just to continue a little bit more of simplifying, we're going to get f prime of x is equal to negative 3 over 4, 1/2 minus 2 is equal to x to the negative 3/2, which is the square root of x cubed, minus 5 over 4, since these cancel. Right, 10 over 4 simplifies to 5 over 4. So let's go ahead. Let's go ahead and solve this by separating out my terms. And let's see if we get the same answer. So on a new page, I'm going to rewrite our function. So we had f of x is equal to, and I'm going to already rewrite it to 3x to the 1/2 minus 5x squared divided by 2x. So as you can see, I can divide this up, right? So I'm going to rewrite, and I'm going to get 3x to the 1/2 over 2x minus 5x squared over 2x. And if I continue to simplify, I'm going to get 3/2 x to the negative 3/2 minus 5/2 x. Oh, I have a 1 right here, so I'm sorry. This is actually a negative 1/2 right here. 1/2 minus 1 is negative 1/2, okay? Now I'm going to use my basic derivatives, and I get negative 3 over 4 x to the negative 3/2 minus 5 over 2. And if I write this again, f prime of x is equal to negative 3 over 4 square root of x cubed minus 5/2. So if I split these screens, I compare my answers, I have negative 3, 4 cube, square root of x cubed, square root of x cubed, minus 5 over 2. So if I take a look at my math, I didn't simplify correctly over here. This should be a 2. And now I'm at check. Okay? So feel free to use whichever method. Like I said, some methods you should use a quotient rule. Other methods you could use both. But if done correctly, you will get the same answer. Alright, so let's take a look at this problem now. And as you can see, this uses a chart. And so, oops, sorry. Let's go back in here. So let's go ahead and take a look at how we can solve this problem. So it says find the equation of the tangent line of f at x equals 2 given the following table. So this table gives us the values of the values when x is equal to 2. So I have a g of x, g prime of x, h of x, h prime of x, which are going to be beneficial when solving this problem, because as you can see, they generalize some of these terms, and we're going to have to know how to do this when we are solving. So just to recall, I want to make sure everyone remembers the tangent line is y minus y1 times the derivative is equal to the derivative times x minus x1, close parentheses. So I already have my x value, which is the 2, but I also need my y value. So just from like the previous problem, I need to plug in my x into the original function to get the value of y. So I get f of 2 is equal to 3 times 2 squared g of 2 minus 7 over 2 divided by h of 2. So if we follow this along, I get 3 times 2 squared, which is 3 times 4. That's 12. G of 2 is equal to negative 2 minus 14 over h of 2 is equal to negative 1. If I simplify that, I get negative 24 plus 14, which will give me negative 10. This is my y1 right here. Okay, so I'm going to shrink this down just so I have enough room for this problem. Right, and let me get all of it, including that negative 1. So I am going to group this, and then I'm going to make it a tad bit smaller so you can have enough room. Come on, where are you? There you are. Alright, so let's make that a little bit smaller just so we have enough room, and I'll move it over to the side over here. But what I'm missing now is my derivative. So let us find our derivative. I get f prime of x is equal to, well, take a look at this first piece. I have two x's right here, and if you notice, it's a multiplication problem. So what kind of rule do I need to use to take this derivative? Good, I need the product rule. So I'm going to do the first term times the derivative of the second, which is g prime of x, plus the second term, which is g of x, times the derivative of the first, which is 6x, right? Now how do I take the derivative of this right here? Correct, I'm going to have to take it by using the quotient rule. So I have minus, and since there's a minus sign here, I'm going to take the derivative of just what's in the fraction. I'm going to pull out that negative. So I'm going to get the bottom, which is h of x, times the derivative of the top, which is 7, minus the top, 7x, times the derivative of the bottom, which is h prime of x, all over the bottom squared, right? If I do this, now I can plug in 2. So I'm going to use all the functions here to solve this. And I'm going to save space, I'm going to just go directly into our table. And I'm going to get f prime of 2 is equal to 3 times 2 squared is 4. G prime of x, according to this, is 3. Plus g of x is negative 2. 6 times x is 12. 6 times 2 is 12. Minus, brackets, h of x is negative 1 times 7. Minus 7 times 2 is 14. So that's 14. H prime of x is 4 times 4 all over h of x squared, which is equal to 1. So let's go ahead and simplify this. So what we get is f prime of 2 is equal to 36 minus 24. This one is no longer needed, but then I get plus 7 plus, because of those negatives, 56. And if I do just a little bit more math, you'll get f prime of 2 is equal to 75. So now what I need to do is I need to go all the way back and make sure I find the line tangent. So if I write my points, I had 2 comma negative 10. I have a slope of this. So I'm going to use this information to fill this out. So I get y minus y1, which is a negative 10. So this becomes a positive 10, times the derivative, which is 75, times x minus my original x value, which is 2, and there goes your tangent line. Tedious, but follows the same steps every single time. That is the end of this lecture, and so we'll start reviewing for our quarter exam, which is on Thursday, October 4th. Good luck, ladies. Thank you.